Hi, in this demo, we are going to set up different OpenShift clusters across different cloud providers, namely Amazon, Azure, and Google Cloud, to achieve the highly resilient requirements that is needed for that particular application. In this case, the application is an e-commerce web page that serves different customers across different parts of the world. And the requirements from the business owners is to ensure that there shall not be any outage to the application, even if we lost a region from one of the public cloud providers. The screen that you're seeing over here is the front page of the application that we have. We call that the Cool Store demo. As you can see over here, it has different merchandise that is for sale, and user can just click on it and make a purchase by checking it out. We have different microservices running on it. The catalog is leveraging on the Yugabyte database. The ordering component is leveraging on MongoDB. Card services uses InfiniSpan. Inventory again uses Yugabyte DB. We also have the payment component that leverages on Kafka, Knative, user interface leveraging on things like Node.js. So there are various different microservices that makes up this particular application. And they are all running across multiple clouds, different providers in different regions across the world. These are the different components, as mentioned earlier, running across 3 different OpenShift clusters across different public clouds. We have a global load balancer that sits in front, where the user is able to access via the coolstoreexample.com web URL, and he will be able to land on any of this cloud depending on his location and depending on the availability of the region as well as the resources that is available inside the cloud. The 3 classes are connected to each other, leveraging on Submariner technology that is provided by the Red Hat Advanced Cluster Manager. We also have Prometheus, Grafana capabilities to be able to see the metrics on the different clusters, aggregating to a common single pane of glass. We also leverages on Argo CD to do the continuous deployment of the various applications to the various location that they should be in. Argo CD also leverages on the GitOps methodology to prevent any drift in terms of the configurations of all these clusters. And this demo itself really is to simulate a region failure. In this case, we are simulating a failure of the AWS region. We'll proceed to the demo next. This is the UI of the Red Hat Advanced Cluster Manager. It provides a single pane of glass for managing multiple different OpenShift clusters. As we can see from the screen, there are multiple clusters being managed from the Red Hat Advanced Cluster Manager. The Hub cluster runs on the VMware environment running on-premise. The other 3 clusters are running in the 3 separate public cloud providers. We have a cluster set called CoolStop that is created for these clusters. And the Submariner add-on has been deployed on all the 3 clusters running on the different public cloud infrastructures. As we can see that all the connections and agents as well as gateway status are all normal and healthy. This is the list of VMs that is running the OpenShift cluster in the AWS environment. We have leveraged on the managed services, managed OpenShift that is running in Microsoft Azure. We call that ARO. And this is the list of virtual machines that runs in the Google Cloud environment that makes up the cluster in GCP. If we were to look at the topology from a developer's perspective, we have different clusters running the same set of applications in the different public clouds. So this is the view in Azure, which is exactly the same as the one in the AWS cloud. There's no difference at all. And we also have identical setup in Google Cloud itself. The whole environment across different clusters are being deployed using Argo CD. As we can see over here, these are the different applications that have been deployed across the various clusters in a consistent way using GitOps. You can see over here that the microservices for the console is running across various clouds. Now we will begin to add items to the cart. And we can see that the microservices is again running on different cloud providers. Now it's on GCP, just now it was on Azure. And we have now running it on AWS. We'll now simulate a failure of the region. From an AWS perspective, we will set it down to a stop state for all these various instances that's running within the Amazon Web Services. So once we start to shut down the cluster, we should expect no impact to the environment itself. When we do a refresh, we can see that now it's going onto Azure itself, right? The shopping summary runs on Google Cloud. Do a refresh, things are working. We go to the cart, we can see that now it goes to Azure. So now it's GCP. It's actually showing that everything is working properly, no longer going to AWS. Now we are trying to check out to prove that the services continues to work normal. Once we hit the checkout button, we can see that the order is being processed. And if we were to check in Google Cloud, the payment is being processed by the payment port. And once we do a refresh, we will see that the payment has been processed. And everything continues to run as is. We can see that the whole environment is running properly. This demo shows that we are able to build a highly resilient architecture with applications that span across multiple different clusters, across different multi-clouds setup that survives even a region failure or a cloud failure. Thank you for watching the demo.